we discussed the nature of the motion of planets. Most of the time it's from west to east, prograde, but every now and then they reverse the direction of motion. And the question is how to fit this into the Aristotle model of geocentric universe. So they actually had to invent a system of epicycles to describe the motion of planets. And let me explain what the epicycles are. Imagine that you have a bicycle wheel mounted horizontally, right? And then at the edge of the bicycle wheel, you have a platform in the form of a disc that is also spinning, and there is a little ball mounted at the edge of the disc. So what would be if both the wheel and the disc are spinning in the same direction? What would be the trajectory in space of this ball? And it would form these loops, these epicycles, okay? So in other words, in epicycle system, you have that planets are moving along small circles whose centers are moving along a bigger circle. And as a result, the trajectory of the planet has this loopy shape. So basically, the prograde motion corresponds to this direction of motion, and then when they reverse the direction of motion, the planet is actually undergoing this motion along the loop, and so on, right? Again, prograde motion, and then here it reverses and moves in retrograde motion, and so on, okay? So this is the system of epicycles that they had to invent in order to explain the motion of the planets. Now, this thing tells you that your theory, the geocentric model, is in trouble. In science, as in everyday life, once you need to complicate things more and more in order to explain things happening around you, usually means that your starting assumption is wrong. Okay? So, hallmark of a correct theory, of correct assumption, is that actually you don't need to do anything to it in order to account for many, many things that you observe, also predict new observations, account for observations in the future. But if you need to modify the theory, to tweak it all the time, to account for larger number of events, the odds are that your starting assumption, in this case, the assumption of the Earth-centered universe, is wrong. Okay, and then you have to actually revisit your basic assumption and see what is happening. Heliocentric model, we can understand this retrograde motion of planets much more naturally. It turns out that the closer the planet is to the sun, the faster it moves, the bigger its orbital speed is. As the distance from the sun increases, the orbital speed drops. So in this case of the Earth and the Mars, the Earth is moving faster in its orbit around the sun than Mars. So at some point, when Earth is here and Mars is here, we see it in the background of stars to be located at this position 1. Then sometime later, when the Earth is here at 2, it has moved this distance, but because the Mars is slower, it has progressed smaller distance, right? Nevertheless, we see Mars to be here against the background stars. But then, between 4 and 6, if you will, the Earth is overtaking Mars. So from the vantage point of Earth, it looks to us as if the Mars is lagging behind. And what is happening, the Earth is simply, because it's moving faster, overtaking the Mars. And to us, moving together with Earth, it appears as if the Mars started moving backward. But it hasn't. It simply continues to move along its orbit around the Sun. It's just been overtaken by the Earth, right? So then we have, for a while, from 1 to 4, we have prograde motion from west to east. And then from 4 to 6, we have retrograde motion from east to west. And then things normalize again after 6, starting from 7, 8, and so on. Then to us, it appears that Mars continued moving along the same direction. Okay? So this is how the retrograde motion of planets is understood within the heliocentric model. So epicycles basically are, so if this is the Earth, the trajectory of a planet is obtained as follows. You take that the planets are moving along small circles whose centers move along the bigger circle. Right? So the end result is basically that you get this looping trajectory, right? So these are the epicycles.